So hello and welcome friends to our channel Intro Make, where we discuss about basic mechanical engineering concepts and many other things which are related to industrial automation. So guys, we have started our new series related to the industrial robots, and in our previous session we learned about some basics of the robots. Now in today's session we will see what are the different joints, links of the robots, what are the different terminology, anatomy involved in the robots. So without wasting time, let's get started. So first is manipulator. So manipulator consists of joints and links. Now links are nothing but the rigid members. So the robot will be having some rigid structural members, and when we join these links with some movements, they form the joints. Now the joints can be linear or rotary, and each joint will be having some degrees of freedom, and most robots will possess a degree of freedoms of 5 or 6. Now let's check out, this is the robot base. Now let's consider we have link 1, this is link 2, and this is link 3. Now these are just links, they will not have any motions in between them, and we want to have the motion. So what we have to do, we will be having the joints. So these are nothing but the joints. When two links come together to have some motion, it forms a joint. Now this joint can provide a linear motion or rotary motion depending on the construction of the robot. So here we can see, depending on the terminology, the parts can be said as a vest, then it has a shoulder, elbow, and a wrist. The wrist is nothing but the end part of the robot to which we attach our tools. So this is compared to our human body, because the robot is nothing but uh, it acts as a human body, it has the links and joints as a human body. Let's check it out how. So here we can see the different joints. So see, we have the joint 1. If we say the ground is link 1, this is link 2, so it forms a joint 1. Then again we have link 1, link 2, it forms a joint 2, and likewise it has different joints. And you can see, we can compare it to our human body, and it will be having motions. As per our human body, it can rotate, it can twist, it can revolve. Then some parts will be having a linear motion depending on the configuration of the robot. So this is the joints and the links, and these terminologies are very important. So what is, then it consists of basically two main sections, so body and arm. So it is for positioning the objects in the robot's work envelope. So this is nothing but the body and the arms, the links. And then the wrist assembly. So the wrist assembly, what we saw is the at the end, and this is nothing but a wrist, and we will attach a end of arm tooling, which is also called as EOAT or end effector. And we will be having some grippers or some kind of actuators over there to pick and place the part, or to have the soldering, or whatever process we want to do. So that is nothing but a wrist assembly. So these are like main components of the robot. Now, what are the manipulator joint configurations? We just discussed about when the links get joined, they form the joints. Now, depending on their motion, we have different configurations. So we can have a translation motion. So if a input link and output link forming a joint, and the joint motion is a linear type, it can be mentioned as L. Then the orthogonal joint. So you can see the configuration of the input link and output link has got changed. So here you can see the input link and output link, how they are forming a joint, and here the input link and output link, how they are forming a joint, and that's why it is called as orthogonal joint. And this can be denoted as a type O, and this can be denoted as type L. Now this L, O, these are important because as moving forward we will see what are the different configuration of the robots, and there these notations will play important role. Now let's check out the next, the rotary motion. Now again, in the rotary motion, we have rotational joint denoted by R, then we have a twisting joint denoted by T, and then we have a revolving joint which is denoted by V. So you can see the joint motions, the input link and output link, how the joint motion is, and this can be very well explained in 3D. Now this is in 2D, but you can imagine what is a twisting moment, what is a rotational joint, and what is a revolving joint, right? So rotational is nothing but it is rotating along its own axis, and twisting it is like rotating like a twist, and then revolving is it is rotating along some other axis. So these are the main joint configurations of the robot. Then we have the wrist configurations. As we discussed, at the end of the robot there will be a wrist, and at the end of the wrist we will attach our end of arm tooling. So this wrist will be having motions like yawing, rolling and pitching. So this is having like 2 or 3 degrees of freedom, which are called as which is called as a motions can be defined as roll, pitch and yaw depending on the axis, uh, right? So this is like a wrist configuration. And now what is the joint notation scheme? We just saw the different joints like L linear, then O, R, T, V like rotational, twisting, revolving. So this will designate the joint types used to construct the robot manipulator, and separates body and arm assembly from the wrist assembly. We saw the wrist assembly, and this is by the semicolon. So the first three letters indicate the motions in the arms, and the part which is separated by the colon indicates the motions in the wrist assembly, and that's why we saw different configurations. Now let's check out if you can recognize or if you can construct how the arm orientations configurations will be. So let's say the first is A, in which we want a configuration as TRT. So that is nothing but the twisting, then rotational, twisting, and again rotational. So let's check out how it will be. So see, we will be having a twisting joint, then rotation, then again twisting, and then at the end of arm tooling, we will be having a rotational joint. Now let's check out if you can do it. You can pause the video, you can check, and you can construct your own, and then you can cross check. So let's have this configuration. So this first one is TR. Now we will have a first one is like twisting. So this will be having twisting motion over here. Then it will be having a rotational motion over here. Then again we this V will be a revolutionary motion, then this will be rotational motion, then again twisting motion, and again a rotational motion. So this forms the TR configuration. Then we have RRT. So this is the rotational, then again we have rotational, and then we have a twist. So this is nothing but RRT configuration. So why we are learning this? Because as we move ahead and we will see what are the different configurations of the robot, these notations will help you to recognize what are the joint motions, and on the basis of that only the different robot configurations are classified. So that is why these things are important and these are basics. So along with that, we have terminologies like reference frames. Whenever we consider the robot, basically we have different reference frames. First is world reference frame, which is like a universal coordinate system. You can see uh, of the frame and defined as XYZ axis. So in this case, the joints of the robot move simultaneously so as to create the motions along the three major axes. Then we have the joint reference frame. So that is basically used to specify movements of each individual joint of the robot. So now in this picture, concentrate. Here we have a joint, here we have a joint, then these are the joints. So when I want to mention or specify uh, the motions at the joints, then this joint reference frame is used. So we will like define the motions at a specific joint, and then we have a tool reference frame, so that specifies the movement of the robot hand relative to the frame attached to the hand. So that is what the end effector or a wrist assembly, because this is kind of a main assembly to which we will have the actuators, we will have the pick and place arrangements, and the different arrangements, right? So how it moves with respect to the main coordinates, because these coordinates are very important when you want to program something. So that's why these references are important. So this is called as tool reference frame. So this is like, you can see x dash, y dash, and z dash, which is attached to the hand, and define the motions of the hand related to the local frame. So these are kind of some basic terminologies. What are the joints? What are the links? Then what are the different motions in between the links? So why those are important? See, the types and configurations of the robot. So here you can now see different configurations are there. First one is like Cartesian, which is also called as a rectangular or a linear. Then we have cylindrical configuration, spherical consideration, articulated configuration. Then there is a specific type called as SCARA, which is a selective compliance assembly robot arm, and then a delta configuration. Now at this moment you might not feel what is Cartesian, what is cylindrical, but just have the patience. In upcoming sessions we will be going through each and every configurations, and you will get to know what is a Cartesian robot, what is a cylindrical configuration, where to use a Cartesian configuration, where to use a articulated configuration, what are the different terminologies that are required to be considered while selecting a robot. So all these things we will be discussing in our upcoming sessions. So stay tuned to our channel. If you have any doubts, please do write into the comment section and we can discuss over there. Until then, keep intro making. Thank you for your patient listening. Thank you.